All right, I'm gonna play a short video. So for the uninitiated, people who don't know about us, cover a few things in a minute.
Imagine if the cloud wasn't up here, but down here, with us. That's Storj. Storj is a cloud shared by the community. It's potentially the largest, cheapest, and most secure cloud available. What you share is what you get. You could even be paid by renting your extra space. But how is it more secure? Each file is shredded, encrypted, and spread across the network until you're ready to use it again. And you can be sure the files are safe because the keys are in your pocket, not a company's. Only you have access to your stuff. Because the network is shared, you don't have to worry about slow download speeds coming from one place. We're all helping to make the system blazing fast. And if you have some extra space lying around, you'll get paid by users who need more than they can share. It's like renting out your empty hard drives. A cloud with security, no downtime, and speed at a fraction of the cost.
So how many people here use the internet to store data? Just raise your hands. Okay. And of those people, raise your hands if you would like a little bit more control over your data. You don't want people and corporations thumbing through it. Okay, so we're at the right conference. That's good. So we're about building a decentralized file storage network that gives that power back to us, the users, rather than a corporation or an application. And so this is built around users who share their excess hard drive space, and they're paid for that service. So instead of being stored in a central data center or service, these are stored on multiple people's PCs, so there's no central entity controlling that. Only the users have control and access of that data. And our job at Storj is to help build and facilitate those tools to make that very simple. So we're built around encryption rather than trusting a particular provider. So the data is sharded and encrypted locally on your PC, and it's encrypted with keys that only the user, you, has access to. Not us, not any third party, just you. And all the code that touches the data is open source, so you can make sure that we're not doing anything funky with the data or siphoning it to an NSA data center somewhere. And there's been a real large demand from this for our community. We have about 20,000 people in our community, on our mailing list, about 5,000 people on our Slack. And they've been helping us since about August of last year help build this out. We do things live. We put out software early and often, and our users give us real live feedback and data that we use to make the next choices. And so we've had about 1,200 farmers in this network, and an aggregate capacity about 3.4 petabytes, which is a lot of data. There was a lot of questions very early on, like, would people even share their hard drive space for money? And the data pretty much proves that they will do so, and they have a lot to give. So there's one really cool aspect of distributed networks that you get out that you don't get with traditional systems. That is, as the network becomes larger, it becomes more secure. You can kind of think of it like storing the data being encrypted bits of sand on an encrypted beach, where only you know where those bits of sands are and only you have the keys to access that data. So as more people come on the network and there's more files stored on the network, that beach gets bigger. And so that becomes very hard for an attacker who's trying to get at that files that doesn't know where those things are and doesn't have the keys to it. And again, that problem gets harder and harder as there's more data on the network. So tomorrow, if you are still in Berlin, please stop by our open beta launch party. So we've been working very tirelessly for about 2 years, getting the supply side of the network up and running, getting users sharing their extra hard drive space and providing the space for the network. And tomorrow we're launching our developers tools for people to actually use this space. So to be clear, we're not trying to build a kind of a next-gen Dropbox. We're trying to build an object storage platform for developers. We see these are the people who can actually get this technology in the hands of the users. A lot of people are trying to focus on, what the next gen application could be. What we're really focusing on is, hey, let's take this tool set, boil it down as simple as possible, putting data on the network, getting an identifier, using that identifier to pull that data back, making tools that does all of that in the background, and give this tool set to developers who can build into new applications and existing applications, and really sell the feature sets and the benefits it provides that include security. So a developer saying, hey, I'm building an application, do I want to use something like Amazon S3 that was built a decade ago and is very old, or do I want to use a newer platform that has end-to-end encryption built in, data security built in right into the foundation, much faster, half the cost, and all these other features and benefits that come with the platform, rather than using these antiquated systems that aren't very secure. And so we see it as a value prop as a whole, as a network that developers can use to, again, provide these tools to these users. So it all comes back to kind of the core concepts around this conference is security and privacy by design. Baking this into the core protocols, offering this as tools that are easy to use, that people don't have to think too much about, okay, I want to provide end-to-end encryption to my users, do I have to build this out, or can this be provided in the tool set? So we're building out this tool set, again, to help developers build these next-gen applications that have these core concepts in mind. So that's it for this. I have a short video that I could show, but I think we have some time for questions as I pull that out. All right, so this is a very quick demo of our command line tools that we just put up here today. It's showing us streaming a video live from the network, and it just, again, boils all these very, very difficult peer-to-peer networks and encryption and streaming down into a very simple tool set that developers can use. So if you want to come talk to me afterwards, I can show you a little bit more in the tool set, but this is just very simply showing that here on the screen. So questions? I think we have 7 minutes left. Yes?
How do you make these files so easily addressable?
Essentially, when you're storing a file on the network, it's an object store. So you store a file on the network, you get back essentially an identifier for that file. And that identifier for the file is mapped to the locations on the network, but that stuff is handled all by the tool set. So all you have to do is push the object, the data, the video, whatever, you get that identifier back, and you keep track of that identifier, and then when you want that file back, all you have to do is push that identifier into the tool set, and it'll take care of retrieving the file, putting it back together in the right order, decrypting it, and just giving you a file out on the other end.
Sorry, how can I go wrong? I'm just really worried about what happens on your end that I would have to deal with that might go wrong.
So I guess the tool set is built to, again, handle a lot of that, so the end developer doesn't have to mess with it, and it just works as intended. I guess the thing would go wrong is if you're somehow making modifications to the code and it's not doing as it's intended. So again, that's all taking care of the core libraries that we build out for the developer, and those are all open source for people to make sure they're doing the intended actions.
Hey, I'm Mark here from the New York Times. Yeah. You said you're half price versus sort of the big boys. Walk me through how that works.
So since we're building this network on people's excess resources, there's a lot of cost cut out. So you're talking about a normal data center. They have to run the lines, provide the power, the electricity, heating, cooling, the staff to maintain this. For this is a program that you can go download on your computer now. You download the application, put in a few fields, you hit go, and it takes care of everything behind the scenes and in software. And since you're already paying for the electricity and the internet and all those other things, those are just sunk costs. And so we pass that savings along to the users who actually, and developers who are storing the data. And so it's a lot more efficient and a lot more cost effective than some of the traditional solutions.
It reminds me of SETI way back in, what was that, the 90s, 2000s? And a little bit broadcast.com, Mark Cuban's thing. I'm not comparing it service-wise. But those companies that, wow, it was amazing, and they failed because the infrastructure and all that stuff wasn't in place. I think you've answered this already. Why will you succeed today in 2016 where they failed?
It's mostly around both the tool sets and ease of use and the incentivization. You look at something like SETI at home, where people, have the feel good to join the network and build it out, and it's built to a pretty large network. There's also folding at home that does, cancer research and protein folding. But then you look at Bitcoin, which took that same problem and incentivized that. And in 2012, when I got involved, the Bitcoin network was larger than the top 500 supercomputers combined. So it's the idea of adding that incentivization to the problem is like, okay, why would I do this? Why would I take the time to set this up? That really makes it a powerful network. And then again, having the tool set so it's not very difficult to use. I remember back in 2012, to get things working in Bitcoin, you have to compile the code yourself. And now there's much more tool sets to be able to use it easily. More questions? All right, you right there.
If I want to share a video with my friends, what is it for this purpose also, or only for my own data?
So we're coming in at a little bit of a lower level. So everyone's familiar with Dropbox. They're a top-end application, but they don't store, for a long time, they didn't store their own data. They just shipped it to Amazon through Amazon S3 to take care of that. So we are that lower level. If you want to share your video or whatnot with a friend, you would do that through an application, and we'd just be the data layer that sits underneath that facilitates that and makes that happen. But the top-level application that allows you to click a link or share that with a friend, that's done at the application level, one level above us.
But what if somebody wants me to take the video down? Is it possible to make censorship here?
So for this, we devised essentially an opt-in process. So me as, I live in the United States, I might want to follow DMCA law, so I might opt into a gray list that says, okay, if you find copyrighted content on the network that's exposed, you can remove it from my computer. But someone who lives in Sweden, that might not apply. So that's not something that they're going to opt in. So we do that by user choice and have the user have the ultimate control over that, not us as a company or the network. That's completely user controlled.
Yes, but the government could come to me and say, take the video down.
So for that particular point, then yes, you would want to take the video down. But it's kind of the point of torrenting, right? Like, how do they go and take that video down? It's very difficult to go discover those users and take it down. And again, it has to be in a jurisdiction where they can actually do that. Other questions? Go all the way back here. In the blue shirt, yes, you.
How do you deal with large parts of the storage dropping out by people switching off the computers?
So there's multiple redundant copies with parity chunks in the network, and we're constantly auditing those pieces to make sure they're available. So if your laptop drops off the window, we're saying, oh, hey, he's gone offline. Let's go take one of those redundant copies and put it elsewhere. So we use something called Reed-Solomon, which basically means we break the file into 40 chunks, of which you need 20 to recover the file, any 20. So you would need to lose 21 pieces of the file absolutely simultaneously. And if that's the case, and that's on a globally distributed basis, if that's the case, there's probably something wrong that's, way worse than you not being able to access your file, like a comet's hit the Earth or something like that. So, all right, I think we're out of time. Thank you, and come by if you have any questions.